A warm welcome to all of you. Today we will discuss about the types of data in machine learning. Types of data in machine learning. Data is a crucial component in the field of machine learning. It refers to a collection of observations, measurements, or records that are used to train the data, validate the data, and test machine learning models. The quality, quantity, and the relevance of data plays a vital role in determining the accuracy and the reliability of a machine learning system. Machine learning models analyze data to discover patterns and relationships between input variables and target outputs, which are then used for prediction or classification tasks. Data can exist in multiple forms such as numerical, categorical, time series, text, images, and audio, and can be collected from sources like databases, spreadsheets, sensors, APIs, and web platforms. You can see classification of data based on labeling. In machine learning, data is broadly classified into two main types based on the availability of data. Data it is being classified into two types: labeled data and unlabeled data. Labeled data consists of input features along with a corresponding target or output variable. Labeled data consists of input features along with a corresponding target or output variable. The label represents the correct answer that the model is expected to learn and predict. Labeled data is primarily used in supervised learning, where the model learns by comparing its predictions with the known outputs. In fact, here in labeled data, majorly it is belongs to supervised machine learning. A supervised machine learning, the features and target variable, the target variable specifically will have labels. For example, in the case of diabetes risk prediction, the target variable, the health condition of a patient, two labels: diabetes, not a diabetes. So therefore, in labeled data, the outcome variable specifically will have a label. Examples: emails labeled as spam or not a spam, student data with final grades, medical record labeled with disease diagnosis. The next one is unlabeled data. Unlabeled data contains only input features without any associated output labels. Basically, the unlabeled data, whenever the data it is not labeled, the extent we can able to perform over there, we can group the data into different clusters. We can form different groups. We can form different clusters. The model must discover hidden patterns or structures on its own. This type of data is used in unsupervised machine learning. Example, the web browsing logs. As per the browsing history, we can able to classify the browsing data into different groups. The less than 18 years people, what kind of websites that they are browsing. 18 to 25 category of age people, what type of websites that they are browsing. And 25 to 40 age group of the people, what kind of websites that they are trying to browse over there. So in unlabeled data, we will not have a specific prediction. The entire data will be in the form of features. The maximum task we can able to perform over there, we can able to group the data. And the next one is classification of data based on nature. The first one, numerical data. Numerical data represents measurable quantities and can be used directly in mathematical operations. This data type is commonly used in regression and optimization problems. Example, age of the person, salary of the person, temperature, distances. So what not numerical data, we can able to quantify the data in numeric aspects like kgs, centimeters, millimeters, degree Celsius, Fahrenheit, millimeters, grams, cost, price, all these kind of measurements we can able to quantify in terms of numerical aspects. So this kind of data will fall under numerical data. The next one is categorical data. The categorical data represents qualitative information in the form of categories or labels. It cannot be directly used in most algorithms and usually requires encoding. Example, the gender we can able to categorize into male and female. Blood group we can able to categorize into uh, A group, B group, and O positive, O negative, AB positive, B positive. So here we can able to categorize the uh, data into different classes. The type of the fruit we can able to classify whether it is a banana, apple, orange, mango, right? Marital status, whether the person is married or unmarried. So this kind of data will fall under categorical data. So the next one is ordinal data. Ordinal data is a special type of categorical data where the categories have a meaningful order, but the difference between categories are not numerically measured. So ordinal data can also be called as rank order data. You can able to arrange data either in ascending order or descending order. So ordinal data will have a specific meaning. Lower the rank, higher the value, higher the rank, lower the value. So rank order data either we can able to arrange in ascending order or descending order. The examples: customer satisfaction level, low level satisfaction, medium level satisfaction, high level satisfaction. Educational levels: schooling, college, university. Clothing sizes: S size, M size, L size, XL size, double XL size. All these kind of data will fall under rank order data or ordinal data. The next one, different forms of data in machine learning. Basically, we can able to categorize into structured data, unstructured data, semi-structured data, metadata. Structured data is highly organized and follows a predefined format, usually stored in tables with rows and columns. It is easy to analyze using traditional databases and machine learning algorithms. Structured data, it is in the form of a table which is a combination of rows and columns. The best example for structured data: Excel sheet, SQL databases, and MS Access related, and student records. All these things will fall under structured data. And the next one is unstructured data. Unstructured data does not follow a fixed format or schema. It is complex and requires advanced techniques such as deep learning and natural language processes for analysis. The best example: text documents, images like JPG images, PNG images, GIF images, BMP images, TIFF images, audio data, video data, and other sort of PDF documents. And all these things will fall under this unstructured data. For analyzing unstructured data, it is a little bit complicated as compared to structured data. So the next one is semi-structured data. Semi-structured data does not fit perfectly into tables but contains tags or marks that provide some sort of structures. So semi-structured data, purely it is not a structured and purely it is not a unstructured. It is a combination of both structured and unstructured data. Example: JSON files, XML documents, HTML pages, and log files are the examples for this semi-structured data. The next one is metadata. Metadata is data about data. It provides descriptive information that helps to understand, manage, and use other data more efficiently. Example: file sizes, file types, creation date, image resolution, and formats, and author and timestamp information are the best examples for this metadata. The next one is, how do we split the data in machine learning? In machine learning, splitting of the data will happen in three different ways: training data, validation data, testing data. Training data is a portion of dataset used to train the model. The model learns patterns and relationships from this data by observing both input features and output labels. Example, historical sales data used to train a sales forecasting model for future prediction purpose. Past student performance of student related data can be used to predict the future performance of a student. So validation data, it is used to validate the performance of the model which has been developed with the help of trained data. So validation data is a data which will be used to assess the performance of a model which has been developed with the help of trained data. Validation data is used during model training to evaluate performance and fine-tune hyperparameters. It helps prevent overfitting and ensures better generalization. Example, a portion of image data used to tune a conventional neural network model during training. Sample user behavior data used to adjust recommendation system patterns or parameters. Now the next one is testing data. Testing data is used to predict for unseen data. Testing data is used only after the model is fully trained. The model predicts outputs without seeing the actual labels, and performance is evaluated by comparing predictions within true outputs. This provides an unbiased assessment of model accuracy. Examples: new exam scores used to test a student performance prediction model. New sensor readings used to test a fault detection system. So testing data is a new data and unseen data. We are trying to predict for this unseen data with the help of developed model. With the help of developed model, we are trying to test for unseen data. This data we call it as testing data. There are some other data types also available, like time series data. Time series data specifically will have a timestamp. This time series data can be, suppose, monthly sales like January, February, March, April sales, and weekly sales and hourly sales, and all such kind of assessments will fall under this time series data. And the next one is text data. Text data is unstructured data represented in textual form. Example, emails, reviews, social media posts are the basic examples for this text data. The next one is audio data and video data and image data. Image and audio data are used in computer vision and speech recognition tasks. Example, medical images, face recognition images, voice recordings are the basic examples for this audio data and video data and image data. Thank you.